Okay, so let's solve some simultaneous linear equations. So today we're going to solve y equals x plus 1. So this is equation number 1. X plus y equals to 3. This is equation number 2. And we're going to solve this by the process of substitution. Substitution just means where you see one thing, replace it with something else. So in this case, y is the same as, so y over here is the same thing as x plus 1. So what this is going to do for us is wherever we see y, we are going to substitute it, we're going to change it and put in x plus 1. So let's go to this equation number 2, and then we're going to rewrite that, but instead where we see y, we're going to put x plus 1. So here we're going to say x plus, we're not going to say y, but we're going to say x plus 1 because y here equals to x plus 1. So we're going to have x plus 1 equals to 3. So now we have written equation 2 differently. So x plus x is 2x. So if you think, let's say x is an orange, one orange, two oranges. So this is 2x's plus 1 equals to 3. So we're going to reduce this. So we're going to say 2x. Now we're going to keep everything with x on one side of the equal sign, everything without an x on the other side of the equal sign. So we're going to say equals to 3, and we're going to take this 1. So we're going to take number 1 over here, and then take it all the way, take that off. We're going to take this number 1 here, and we're going to take it all the way across to the other side of the equal sign. But remember, anytime something crosses the equal sign, that's the sign in front of it changes. So here, this 1 is actually plus 1 because the sign in front of it is a plus. So and when we take it over to the other side of the equal sign, it's going to become a minus 1. So we're going to have minus 1. So this plus 1 becomes a minus 1 because it's gone from being on this side of the equal sign over to this side of the equal sign. So here we're now back to 2x equals 3 minus 1 is 2. So 2x equals to 2. Let's put that over here. So we're going to divide both sides of the equation by 2. So divide this by 2, divide this by 2. So we're going to cancel these across because 2 and 2 divided by 2 is 1. So x equal to 2 over 2, which is 1. So 2 divided by 2 is 1. So x equal to 1. We're not done yet. Now we know what x is. We remember we need to still solve for y, because when we solve these things, we're solving for both x and y. So now that we know that x is equal to 1, we're now going to go back to any of these equations. So we can go back to, let's use equation 1. So we're going to rewrite equation 1. But now wherever we see x, we're going to put 1. So now we're going to say y equals x, which is 1, plus 1. So y equals to 2. So now that we've solved our equation, we know that the final answer is x equal to 1 and y equals to 2. And we can substitute, and I always say check it back by replacing these things in both equations. So let's find some space somewhere else to do that, and let's do it in a lovely pink color. Okay, so over here, so we're going to say y, what did we say y is? Y is 2. Okay, 2 equals to x is what? 1. We said x is 1 over here, remember? So x is 1 plus 1. So 2 equals 1 plus 1, which is 2. 2 equals to 2. Correct. Love it. And we can test it in the other one. Again, x is 1. So x here is 1. 1 plus, sorry, let's take that off. So 1 plus y, which is 2. 1 plus 2 equals to 3. And we know that 1 plus 2 is 3. 3 equals to 3. So this is just one way to double check your simultaneous linear equations, you can put the answers back and both sides of the equation should be the same. So there we go. Thank you.